Right, welcome. So this is the first video in your AS flipped classroom. And in this module, we're just going to start looking at some fundamental concepts and just get you used to the videos as part of the flipped classroom, because you probably haven't had your class set up like this before. So we're going to start by going through some key scientific concepts, which you should have come across before. It's mainly to get used to the videos. Then we're going to go through some of the key basic scientific tests which you need to know about to complete your AS level. We're then going to go through some of the key terminology in chapter 1. So this first video is on variables. So how are we going to learn about this? First, we're going to go through what a variable actually is. We're then going to look at the three main variables, the independent, dependent, and control variables, which are very important for when you do scientific investigations. And we're going to try and explain why it is so important to consider these three variables when you are doing a scientific investigation. So first of all, what is a variable? Now, you can have a dictionary definition, which is something which is liable to vary or change. Okay, so think about myself. When you hand in your homework on time to a good standard, I'm very happy. When you don't, I'm angry, a little bit sad. So my mood has varied. My mood has changed. Now, in a scientific investigation, a variable is anything in your experiment which can change. Now let's look at quite a different example, just to get us thinking about the process. So your football team has just bought a star new player. Now your hypothesis is that buying and playing this one player will cause your team to win their next match. So is this a scientific investigation? No, not even close. Let's think about all the other things which could affect the result. Did the other team play to their potential? Did they have an off day? Were there any unusual mistakes which don't normally happen, which couldn't be predicted prior to the match? Did the players get enough sleep the night before? Were they in peak condition to be able to play in this match? Are you playing at home or away, which will have different amounts, different levels of support, which could affect how well your team play? Were there any injuries to key personnel either before or during the match? Did the referee make any large errors, which again could not have been predicted? What was the weather like during the game? Now these are just a handful of variables which could have affected the result of the match. You cannot say that even if you win that match, that was because of the new player. There's so many things which could contribute to the result of that match. So in a scientific experiment, we have to choose variables which we can specifically look at. Otherwise, it is not a scientific investigation. This is a key point. When you are setting up an experiment, you have to be able to set it up in a way that you are only looking at the things you want to look at. So let's have a look at the key variables. First one is called the independent variable. Now, this is the one that you are really investigating. You want to see if this one variable will have an effect on something else. So you change or choose this variable. This is the one you want to look at. Next is the dependent variable. Now you are looking to see if this variable is affected by the independent variable. You're going to try and measure some change in this variable. So it's the dependent variable is the one which you measure. Now, whilst we're here, your independent variable could have no effect on your dependent variable, but that is still a valid result. A negative result can be just as useful as a positive result. So, in a scientific investigation, you will change one variable and you look to see if it has an effect and be able to measure effect on another variable. That would be your ideal scientific investigation. But it's not as easy as that, because there are other things which could potentially affect and change your dependent variable. Therefore, what you are measuring would not necessarily be due to the thing that you chose or changed, the independent variable. So anything which could affect your results, which isn't the independent variable, have to be what is called controlled. So control variables. There can be dozens of control variables that you need to think about in an experiment. Okay? You only want to look at how changing the independent variable affects your dependent variable. Therefore, anything else which could affect your dependent variable is a control variable, because it needs to be controlled. So how do we do this? Control variables, they are having an effect on the dependent variable, but if we keep them the same so that it has the same effect each time, then we say it has been controlled. It is therefore not causing additional changes to your results. So variables that are kept the same are called control variables. Now, you may have heard the term fair test. Now, this is not a term we should be using at AS level. It's a very general term, and you shouldn't be using it in your answers without adding further detail. Okay? But a fair test is basically an experiment which has been done correctly, in that the only thing which affects the thing you're measuring, the dependent variable, is the independent variable. So let's have a look at an example. Does the temperature of a Bunsen burner affect the time it takes for chocolate to melt? Now, if you're not sure what a Bunsen burner is, it's this, okay? The thing which is around me, okay? It's just a piece of scientific equipment used to heat things. So first, let's think about what are our independent and dependent variables. Now, a trick for when you're thinking about this is that a good scientific hypothesis will include those two variables. Okay, so our hypothesis, or the question we're trying to answer, does the temperature of the Bunsen burner affect the time it takes for chocolate to melt? Our two variables, independent and dependent, should be in this sentence. Now, if you think about it, the thing we are choosing or changing is going to be the temperature of the Bunsen burner. The thing we're going to measure is going to be the time it takes for the chocolate to melt. Now, what could potentially be control variables for this basic experiment? I'd quite like you to pause the video, please, and have a think about this. Try and get 3 or 4 variables which might also affect the results. Okay, have you done that? Right, let's go through a few then. Okay, type of chocolate. You've got dark, you've got milk chocolate, you've got white chocolate. Different chemical composition could mean that different amounts of energy are needed for it to melt. Therefore, the type of chocolate could affect your results. The mass, obviously, the more chocolate you have, the more energy is going to be required for it to melt. Therefore, it is going to affect your results. The size of the chocolate, the surface area. The greater surface area, the easier the energy is transferred throughout the chocolate, the quicker it's going to melt. Therefore, it's going to affect your results. Distance from the Bunsen burner to the thing you're melting. Okay, this is actually a common control variable in a range of experiments that you will see. The distance from the heat source to the thing you're adding the heat to has a big effect on how quickly and how much energy gets to, in this case, the chocolate. Therefore, the distance from the Bunsen burner to the chocolate has a big effect on your results. Starting temperature of the chocolate. If you had it in the freezer all night, it's going to be very hard, and it's going to take more energy for it to melt than, let's say, if you left it on the windowsill on a sunny day. So the starting temperature of the chocolate will have an effect. And there could be loads more. There is loads more. But all of these would have to be controlled, would have to be kept the same when you are changing the temperature of the Bunsen burner, or else you will not be able to directly link your independent variable to the dependent variable. So hopefully, by now, you should be able to state what a variable is. You should be able to describe what the three main types of variable are, and you should be able to give details about why it's so important that we think about these three variables when we're setting up a scientific investigation. If you're unsure about any of these points, one of the advantages of the flipped classroom is that you can just go through and watch it again whenever you want. Okay? Make sure you write down your questions on your worksheet, and I will see you next class.